The Pentagon was never supposed to look the way it does. In 1941, the War Department was scattered across 23 different buildings in Washington. Files went missing, decisions slowed to a crawl, and new offices already built were nowhere near enough. America was on the edge of World War II, and the military needed a single headquarters, fast. What happened next wasn't the result of a grand architectural vision, but of urgency, compromise, and a strangely shaped plot of land next to Arlington Cemetery. A shape that, once drawn, stuck, even when it no longer made sense. This is the story of how the most recognizable military building in the world, 5 sides, endless corridors, was born not from design genius, but from a chain of accidents, and how those accidents somehow created an icon. In 1941, the War Department ran a mission from a maze. Its offices sat across 23 buildings in and around Washington. People spent hours each day in transit. They carried paper files that no one else could see at once. Switchboards jammed and lines failed. Bureaus kept their own forms and rules. Work stalled when a memo missed one name. The country stood on the edge of war, yet the staff used a peacetime setup. The map of offices did not match the scale of tasks to come. The so-called headquarters on the mall showed the strain. The munitions building, and the main Navy building, began as a stopgap in the last war. By 1941, they sagged under too many people and too much paper. Leased rooms downtown overflowed with desks and files. Temporary huts spread across the mall and near the river. Rain seeped through seams and soaked maps. Fire codes capped storage, so files stacked in halls. Guards could not seal off rooms that split across floors and alleys. A new War Department building rose in Foggy Bottom. Growth had made it too small before the doors opened. The plan had used a calm year headcount. Then Europe burned, and Congress funded arms and manpower. The new site could not hold the surge. Leaders faced a choice: cram into a tight shell, or design a home for the whole war. They knew a small move would fail within months. The Foggy Bottom building would go to another agency. The department needed a new answer. Brigadier General Brehon Somervell saw the gap and moved. He led the construction division of the Quartermaster Corps. He told his staff to find land, draft a plan, and build a base that could hold the entire department. He wanted a plan that moved work with ease. He knew shape guides flow. He asked how a clerk would move a file in 1 hour, not in 1 day. Lieutenant Colonel Hugh Casey served as Somervell's chief engineer. He could turn a rough sketch into steel, concrete, and a schedule. He took the need for a single home and broke it into parts. He mapped desks, corridors, stairs, elevator banks, and supply bays. He checked truck routes and river access. He planned for records, cable, and pipes. Architect George Edwin Bergstrom joined to give form at scale. He knew how to fit a huge program on a hard site. He worked with Casey on a plan that placed people near the people they served. He drew rings and spines so staff could cross the building in minutes. He placed light courts so rooms had air and sun. He framed wings that could rise in stages as materials came in. He held to the rule that purpose should lead form. The push for one home had a clear aim. War needs command and speed. A scattered map breeds delay and error. Each gap between buildings adds time and noise. Each extra handoff adds risk. The United States could not run a global fight with a filing chain that bent at each block corner. Centralization would not fix supply by itself. It would cut waste born of distance and split control. Case study: a requisition for tank tracks in mid-1941. An armor unit at a training post reports that tracks fail under load. The ordnance desk in one site studies test data. The G4 staff in another weighs transport and storage. The budget office 3 miles distant reviews funds. The judge advocate shop checks contract terms. A call goes out for a design change and a rush order. Each team stamps its form and sends it by courier. One clerk is at lunch. A bag sits in a car that breaks down on the bridge. 2 days pass. A plant waits for guidance. The unit keeps training on worn gear. The chain shows how distance adds drag to each step. The split map warped how leaders set policy. A code room could not reach a policy shop without a chain of calls. Draft memos went out and came back with marks that crossed in the mail. Branches built small empires because distance gave cover. A turf fight could tie up a large task. The paper trail grew, and control shrank. Somervell rejected that waste. He knew the department would direct millions of men and tons of material. He saw that space could shape speed. If you could move from G1 to G2 to G3 to G4 on one floor in minutes, you could act as one staff. If you could send a file through an inner ring and reach any office in minutes, you could keep work hot. If you could stack records near the people who used them, you could curb loss and leaks. If you could fit a plan to roads, rail, and a river, you could feed the place with ease. Hasey turned those needs into counts and loads. He fixed hall width to let 2 carts pass. He placed ramps so clerks with carts did not wait for lifts. He drew a grid for cable trays so signals work could expand. He chose a frame that used less steel, since steel had to go to guns. He kept spans tight to save material. He broke the job into stages so staff could move in as wings came online. He set crews in shifts and put batch plants near the site. Bergstrom kept the plan human. A building that holds tens of thousands must feel clear. He placed restrooms, stairs and cafes where people needed them. He made corridors straight so you could see your goal. He set doors to match the rings and spines. He let light reach deep rooms. He shaped the first scheme to a 5-sided plot. The form came from the land, not from a wish to stand out. The point was to serve the work. Time pressed on every desk and every urgent decision. The first site sat on the Arlington Experimental Farm, beside the National Cemetery and the ridge above the Potomac. The field did not square off. Roads and old fences cut it into a crooked figure. Surveyors marked the limits and saw 5 sides with odd angles. The outline looked like a rough pentagon. No one set out to draw a symbol. They traced what the land allowed. The team chose to fit the building to this outline. They did not try to force a box into a broken frame. A match would save time and cut waste. Shorter walls would use less steel and concrete. A 5-sided footprint would place people closer to each other. A clerk could reach another office in minutes, not a half hour. Shape and site drove each other. The cemetery and memorial bridge set height limits. The ridge, parkway, and river bent access roads. The water table discouraged deep basements. The plan spread out and stayed low. It tucked service courts into the angles and left room for truck aprons, rings inside the shell set routes for people, cables and pipes. Spokes linked the rings so no one got trapped in cul-de-sacs. Light courts opened the interior to air and daylight. This is how the shape took hold. Engineers and the architect sketched a 5-sided shell to meet the survey. They drew 5 wedges around a court. They linked them with concentric rings. They made each wedge a module that crews could repeat. The result used simple geometry. From any point you could reach any other in a few turns. No path ran the full length of the building. Dead ends vanished. The odd outline echoed a much older type. On the paper, the sides and angles called to mind the star forts of the gunpowder age. Those works used triangles and points to control space, yet the math behind both ideas was the same. Angles remove blind spots. Short lines and many connections reduce delay. A plan that fits its setting wastes less effort. The match to the farm created the shape. The resemblance to forts came later, as a side effect. Fort Bourtange in the Netherlands shows this link. It sits on flat ground near a narrow road that once controlled a border. The fort has a star plan with 5 main points. Each point is a bastion, an arrow-shaped bulge that faces out. Water and earth ring the works. A glacis slopes away to strip cover from an attacker. The curtain walls between bastions meet at oblique angles. From each point a guard can watch and support the next. Walk the ramparts in your mind. A sentry moves from one bastion to the next along the wall. He can see the ditch, the next face, and the ground beyond. If a threat appears, the next point can fire across the front. The ditch slows an assault and also drains the field. The earth bank resists cannon, and also insulates powder stores. Now compare that to the farm plan. A messenger moves along a ring to a spoke and into another ring. If a hallway clogs, he can shift to the next ring and keep moving. Service lines follow the same idea. The angles cut down long, noisy corridors. The courts pull light and air to the core, and offer simple fire egress. The layout gives many short, clear paths rather than a few long ones. Picture a day, if the designers had used a long block instead. Trucks would crowd a single dock. Couriers would walk one big loop and lose time at each turn. A fire door could stall movement across the whole floor. In the 5-sided plan, each face can host its own dock. Each wedge can run on its own risers. Crews can shut a section for work while the rest stays open. The site later moved away from the farm, but the shape stayed. By then the team had learned that the five-sided form solved more than a boundary problem. It solved motion, clarity, and supply. It saved steel in a time of rationing, because floor spans stayed short. It allowed staged work because each wedge could rise with little harm to the whole. It kept the height down and spread the load over weak soils. The Fort case offers more detail on those rules. Portage adds outworks like ravelins and covered ways. Each piece extends range, controls approach and sheds water. In a headquarters, you see cousins of those parts. Perimeter roads and guard posts control approach. Courtyards act as safety buffers, and also stage gear. Service corridors carry conduit, and also serve as fire breaks. The best plans make each foot of space do 2 or 3 jobs. The cemetery next door also set a tone. The building could not loom over graves or block the view to the bridge. A low, broad mass fit the duty of the place. It kept the ridgeline open. The five-sided plan made that easier than a tall tower would. The outline looked new but did not shout for attention. It also eased traffic on nearby roads. 5 fronts let planners spread gates and parking. Buses could stop at more than one side. Pedestrians could enter close to their desks. The plan lowered daily stress for staff and guards. Small choices like these scale well in a place that never sleeps under pressure. Seen this way, the origin of the shape is simple. The land at the farm had 5 sides. The program had to move people and paper at speed. The team drew a plan that fit both. The lines recall a star fort because both respond to the same facts of space, strain and time. Each seeks to remove blind spots, shorten trips, and use the ground rather than fight it. Start with the ground, keep function in mind, and the drawing tool often swings to the same angles. The push to build on Arlington Farm met strong resistance. Gilmore D. Clark, chair of the U.S. Commission of Fine Arts, looked from the ridge at Arlington National Cemetery and saw risk to a central civic view. He argued that a huge headquarters at the farm would break the axis from the Custis Lee Mansion across Memorial Bridge to the Lincoln Memorial. He warned that the mass would overwhelm the approach to a national shrine. Clark viewed the vista as sacred ground. Frederick A. Delano, the president's uncle and chair of the National Capital Park and Planning Commission, raised different alarms. He focused on traffic, bridges and parking if tens of thousands crossed the Potomac each day. He doubted that Memorial Bridge could absorb the load. Delano and Budget Chief Harold D. Smith took the case to the Oval Office and urged a smaller staff count and a different site. Roosevelt listened. The debate grew in Congress and in the press. Critics said the scheme ignored the Capitol's plan and would saddle Arlington with heavy costs for water, sewer, and roads. The outcry forced the War Department to defend not only the need but the place. As tempers rose, the president weighed both the art of the city and the war need. He chose to act. On August 19, 1941, Roosevelt told reporters he leaned against the Arlington Farm site. He recalled his role in placing World War I buildings on the mall and called it a mistake he would not repeat. He said a permanent block at the foot of the cemetery would mar the setting for a century. Days later he toured Virginia with Clark and Somervell. They stopped at a low tract south of the farm, near the old Hoover Airport and the river flats. Locals called it Hell's Bottom. Shacks, sheds, yards and dumps spread across soggy ground. Somervell disliked it, but Roosevelt pointed and said the building would go there. The new site eased the aesthetic issue. It also added hard work. Crews would clear slums, reroute roads and drive piles into poor soils. The traffic worries did not fade. The bridges still needed a road network that could feed the base without choking the city. The Bureau of Public Roads and the Army drew cloverleafs and ramps that became the Pentagon road system. The move raised a design question. The first Pentagon matched the irregular outline of the farm plot. On Hell's Bottom, a rectangle or square would have worked. Clark and several members of the Fine Arts Commission said a rectangle would be easier to read and safer. They warned that a 5-sided plan would confuse visitors and make an inviting bombing target. They urged a straight scheme. Roosevelt heard them and then said he liked the Pentagon because nothing like it had been done that way before. Why keep the shape when the land no longer forced it? Speed topped the list. The team had a working scheme, a grid of rings and spokes, and a material takeoff that met wartime limits on steel. Starting over would burn weeks they did not have. They kept the plan, and with the farm's constraints gone, they regularized it into a true pentagon with equal sides and clear geometry. Function argued for the shape as well. Short walks between any 2 points, direct crosslinks and balanced wings cut lost time. 5 front spread entrances and service yards. The rings carried power, pipe, cable, and people in layers. Spoke corridors moved files and orders to the center and out again without jams. The plan kept height low, out of respect for the cemetery, while fitting a vast floor area on a shallow foundation. The outline served the work. Picture a simple case. A staff officer needs signatures from GO1, G3, and budget. In a long bar building, he walks the length, waits at lifts, and repeats the trip to return to his start. In the Pentagon, he cuts across an inner ring, turns twice, and arrives. If a corridor blocks, he shifts to the next ring. The same logic guides messengers, repair crews, and line workers. It saves minutes on each trip and hours across a day. Politics played a part too. By early September, the design had momentum. Contracts, drawings, and early site work were in motion. Each new change risked a fresh round of review. Somervell's team knew that facts on the ground win arguments. They drove piles, set forms, and framed the first bays while the last debates simmered. When the commission returned with a plea for a rectangle, the president approved the Pentagon. The move to Hell's Bottom had a social cost. The government cleared more than 100 homes and businesses around Columbia Pike. Court fights followed. Families who had lived there for years had to leave so roads and parking fields could spread. The record notes those losses in spare terms amid the rush to build. Roosevelt also tried to cap the staff count. He said the building should hold only 20,000 to ease the crush on bridges and streets. Somervell agreed in the room, then pushed the total back toward the original figure as the crisis deepened. After Pearl Harbor, the headcount rose, a 5th floor appeared, and the pace quickened. The traffic fears were not idle, but the new road system and bus loops helped carry the load. In the end, the shape stayed because it met need, saved time, and fit the moment. It grew from a site rule, survived a move, and proved sound in use. The Pentagon solved movement and supply inside the walls and gave the builders a form they could raise fast on bad ground. Clark guarded the view. Delano forced the city to think about flow. Roosevelt chose a rough tract and kept the project alive. The 5-sided plan bridged those aims and went to work. The Pentagon's shape worked because it reduced wasted movement. The rings and spokes gave many short direct routes between offices. In a rectangular or block design, people walk long corridors or must detour around dead ends. The 5 equal sides allowed any office to be reached from any other, with no more than a few turns. Studies showed this cut walking distances by 30 to 50% compared with standard plans of the same size. In a building with thousands of employees and constant face-to-face work, every saved minute mattered. A clerk carrying a file from personnel to logistics could cover the distance in 3 minutes instead of 7. A messenger running a map from intelligence to operations could use a single spoke and be at the door in half the time it would take in a grid. Multiply that by hundreds of trips each day, and the time saved became a form of extra manpower. The design also worked because it was easy to build. Straight walls made layout simple, and cut the need for custom framing. Curved walls, like those in a circular plan, take more labor to set formwork and more care in cutting materials. The Pentagon's sides and interior rings followed basic geometric lines that crews could repeat without remeasuring every piece. The symmetry meant that once one wedge was framed, the others could follow the same pattern. This let crews work on several sections at once, keeping the schedule tight. It also allowed work to continue even if material shortages slowed one wing, because other wings could still go up. During a war build, that flexibility mattered as much as design beauty. Administrative function gained from the shape's balance. Each wedge could house a set of related offices, with utilities running in mirrored layouts. Electrical, plumbing, and communication lines could follow predictable routes in each ring. Maintenance crews did not need a unique map for each area. Once they knew one section, they could service the others. Symmetry made it easy to distribute heating and cooling evenly. It also meant that supply docks, restrooms, and stairwells could be placed at equal intervals, reducing choke points. When one service route went down for repairs, staff could use another on the opposite side with the same access. The central courtyard created by the 5-sided form gave another advantage. It brought light and air into interior rooms without long shafts. It provided a large open space for emergency assembly or temporary storage. Unlike the narrow light wells in many block buildings, the courtyard was wide enough to be functional. It also gave the interior a sense of orientation. People could look out a window and see the courtyard to gauge their location. The flow of work in the Pentagon contrasts with that of a skyscraper. In a tall tower, most movement is vertical. Staff ride elevators to reach other floors, often waiting in queues. Moving from one department to another can mean riding up, crossing a floor, then riding down again. In a tower, mechanical systems must run vertically through crowded shafts, and when one elevator bank stalls, movement slows for the whole section. If the building houses 20,000 people, peak traffic hours create long waits. A messenger in a tower might spend more time waiting for lifts than delivering documents. In the Pentagon, most movement is horizontal. Elevators are rare. People use stairs for the few vertical shifts needed. To reach another office, staff move along a ring, cross a spoke, and continue along the next ring. The distance is short, and choices are many. If a corridor is blocked, another route is close by. During high-security events, sections can be sealed without shutting the whole building. In a tower, locking down one floor can trap people above or below. A case study makes the contrast clear. Imagine an urgent briefing that needs staff from personnel, operations and logistics. In a skyscraper, personnel is on the 5th floor, operations on the 20th, and logistics on the 33rd. Each group leaves its floor, waits for an elevator, rides to the meeting room floor, and then repeats the process to return. Even if each trip takes 5 minutes, the process eats up a quarter hour before the meeting starts. In the Pentagon, each group walks a few hundred yards through connected corridors, often in less than 5 minutes. The meeting can start almost at once, and staff can return to work without delay. Another example is the handling of classified material in the 1940s. In a tower, moving a secure file from one office to another might mean using an elevator crowded with unrelated personnel. In the Pentagon, the messenger could follow a secure corridor with fewer public crossings. The closed rings and controlled spokes allowed better control over who passed through sensitive areas. This cut the risk of accidental exposure. The horizontal layout also eased the strain on mechanical systems. Air handling, wiring and plumbing could run in continuous loops around each ring. Repairs could be made section by section without cutting service to distant parts of the building. In a tower, vertical runs make it harder to isolate repairs. A single failure in a shaft can affect many floors at once. The Pentagon's low, wide footprint made its systems easier to maintain during wartime, when skilled labor was scarce. From a construction point of view, the 5-sided plan used less steel than a tower of the same floor area. The short spans between supports allowed the use of reinforced concrete with minimal steel reinforcement. This saved critical metal for ships and weapons. Crews could pour floors in a repeatable sequence. Straight outer and inner walls reduced the number of unique form panels needed. In a tower, every floor requires repeating a vertical core and elevator banks, consuming more steel and labor per square foot. The balance of entrances in the Pentagon spread the flow of traffic. Staff could enter at any of several sides, reducing congestion. In a skyscraper, the base often funnels everyone through one or two lobbies, creating pinch points. The Pentagon's arrangement let deliveries use separate service bays without crossing paths with pedestrian traffic. This not only improved safety, but also kept supply work from interrupting office movement. Even in emergencies, the shape offered benefits. Fire drills could move people to the courtyard or to the exterior without long vertical climbs. Evacuation routes were short and numerous. In a tower, descending dozens of floors by stairs takes time and risks bottlenecks. In the Pentagon, no office is far from an exit. The design also allowed expansion in ways a tower cannot. In later years, sections could be renovated one wedge at a time, while the rest of the building stayed in service. This was possible because each wedge had its own core systems, arranged symmetrically. In a tower, taking one floor out of service often disrupts those above and below. The Pentagon form was not just a response to an old plot of land. It became a working tool for a wartime headquarters. It cut walking time, simplified construction, balanced utilities, and gave flexible, secure movement. The contrast with a vertical office plan shows why the building's shape, even when no longer tied to its original site, remained a sound choice for its mission. Late on a Friday in July 1941, Brigadier General Brehon Somervell called in his key staff. He told them to bring back by Monday morning a complete plan for a new War Department building. It had to be big enough to hold the entire department in one place. He wanted a concept, site plan, floor layouts, and a rough estimate of materials. The normal process for a federal building could take years. Somervell gave them a weekend. He saw that the slow pace of scattered offices could not survive the war that was coming. He knew that a tight deadline would force decisions and cut delay. The scale was blunt. The first stage had to give 500,000 square feet of usable space within 6 months. The whole project had to be done in a year. That meant crews would break ground before the drawings were finished. It meant work would start while details were still changing. It meant ordering steel and concrete before the final count of beams and columns was set. Somervell pushed for speed over polish. His engineers, including Lieutenant Colonel Hugh Casey, broke the building into repeatable units so crews could work on several sections at once. Colonel Leslie Groves took charge of construction in the field. He had a hard style that mixed blunt orders with close oversight. He drove his staff and contractors to meet schedules, and he measured progress in hours, not days. Groves spent time on the site, inspecting forms, asking about delivery schedules, and cutting through red tape on the spot. He demanded long shifts and 7-day work weeks. Problems that might take weeks to settle in Washington were decided in minutes at his desk or on the edge of a muddy excavation. His speed and command presence came from the same mindset he would later bring to the Manhattan Project, where he oversaw the vast and secret effort to build the atomic bomb. In both jobs he held a large complex team to impossible deadlines and refused to accept the word no unless it came with an alternate solution. To hit the 500,000 square foot mark in 6 months, Groves and his engineers staged the work so that each wedge of the building could rise on its own schedule. Foundations were dug on one side while concrete was poured on another. Structural steel went up in the first wedge while footings were still being laid in the last. Crews worked in shifts around the clock. Lighting rigs turned the site into a bright island at night. Supply trucks were scheduled to arrive at set times to avoid traffic jams on the narrow local roads. The rush brought a clear risk. Errors made in haste can cause cost and delay later, but the team reduced that risk by keeping the design as simple and regular as possible. Straight walls, repeated floor plans, and standard window units meant that once a section was framed, it could be copied without change. The rings and spokes inside the building used the same dimensions from wedge to wedge. Even the stairwells and restrooms followed a fixed pattern. This allowed different crews to work without waiting on unique designs. The sense of urgency on the site matched what was happening in other parts of the war economy. The Liberty ship program in the shipyards offers a clear parallel. These cargo ships were not fine examples of naval architecture, but they could be built fast, and speed was their chief virtue. In 1941, the first Liberty ships took over 200 days to build. By 1943, yards like Kaiser's in Richmond, California, cut the average time to about 6 weeks, with one ship famously launched after just over 4 days of work. They reached these speeds by breaking the hull into prefabricated sections, using welding instead of riveting, and setting up assembly line methods on a massive scale. The Pentagon project used the same principles on land. Prefabrication played a role in door and window units. Materials were stockpiled on site to avoid waiting for deliveries. Tasks were broken down so that crews could work in parallel, each on a different phase. Just as in the shipyards, coordination mattered as much as muscle. One late delivery of steel could idle a whole shift. One mistake in a form could stop a concrete pour. Groves' daily checks and fast decisions kept those stoppages rare. The working conditions were harsh. Hell's Bottom had poor soil that needed piles to support the weight of the building. Crews drove thousands of them before they could pour foundations. The ground held pockets of water that turned to mud in the rain. The summer heat and winter cold did not slow the schedule. If a truckload of concrete arrived in the rain, it was poured in the rain. The race for space also meant parts of the building opened before the rest was done. As soon as one wedge was enclosed and had basic services, staff began to move in. The construction crews kept working on the next wedge while clerks and officers settled into their desks nearby. This overlap was noisy and dusty, but it met the goal of bringing the War Department under one roof fast. Groves' approach did not win him friends among all the contractors, but it got results. In both the Pentagon and later the Manhattan Project, he cut across normal chains of command to solve problems. He could call a supplier's president directly rather than send letters through channels. He pushed railroads to divert cars of cement or steel to his sites. He knew that in wartime, resources flowed to the loudest and most persistent demands, and he made sure those demands were heard. In the shipyards, Liberty ships rolled down the ways into the water with little ceremony because another hull was already taking shape behind them. At the Pentagon site, one completed ring of offices led straight to the next ring going up. Both efforts showed that speed comes from planning for repetition, stripping away frills and keeping work moving without pause. In each case, the product was not meant to be perfect. It was meant to be there on time and ready to serve. By early 1943, the Pentagon's full footprint was in use. Less than 18 months after ground was broken, that speed was the result of Somervell's drive, Grove's control of the site, and the wartime willingness to bend normal rules in favor of the calendar. The demand for 500,000 square feet in 6 months and full completion in a year had seemed extreme when Somervell gave his weekend order. Yet, like the Liberty ship program, it showed that in war the measure of success is not elegance or comfort, but whether the building, or the ship, is ready when it is needed most. Groundbreaking took place on September 11, 1941. By then, grading crews and pile drivers were already working the flats of Hell's Bottom. The plan called for building in a clockwise sequence, starting with one wedge and moving around the ring. As each section was enclosed and had basic services, staff began to move in, even while other sections were still under construction. This meant that office work and heavy building took place side by side, with clerks at desks hearing hammers and saws a few walls away. The original design called for 4 floors. In the early months after Pearl Harbor, the War Department realized the headcount would exceed that capacity. Somervell ordered a 5th floor, added in mid-project. This change required redesigning column loads, adjusting elevator and stair layouts, and securing more materials at a time when steel and concrete were tightly rationed. Crews kept the work moving without stopping the rest of the schedule. They adapted by pouring the added level as each section rose, folding the change into the ongoing sequence. At peak activity, the site employed about 15,000 workers. They labored in shifts, often 7 days a week, through all weather. The job carried constant risks. Moving steel, high scaffolds, open elevator shafts, and heavy equipment in tight spaces led to accidents. Safety rules were enforced where possible, but the pace and pressure meant hazards could not be eliminated. Several workers lost their lives during the project. Reports list falls, crushing injuries, and equipment accidents as causes. In the early 1940s, such losses were common on large industrial sites, and the Pentagon was no exception. Managing such a large workforce brought its own challenges. Housing in the area was scarce. So many laborers commuted long distances. Buses and carpools brought them from Maryland, Virginia, and the district. To keep production steady, site managers had to juggle crews from different trades so that one delay did not stall the entire sequence. Electrical teams followed close behind carpenters. Plumbers and pipe fitters worked in the same tight spaces as drywall crews. Coordination was constant, and 4 men walked miles each day to check on progress. The building soon drew nicknames. Its shape led to the 5-sided puzzle among some in the press. Others called it Somervell's Folly before they saw how quickly it filled. Workers sometimes referred to it as the Big Grey, because of its unpainted concrete walls. Locals joked about the War Department warehouse rising from the mud. As the walls took shape, the size and pace of the job began to shift public perception. The Pentagon became a visible sign of war mobilization, a project that looked and felt urgent. The mixture of urgency and sheer size created unusual stories. One involved Captain Robert Furman, an officer assigned to oversee parts of the build. Furman found himself on site so often, working long into the night, that he set up a small apartment inside the unfinished building. Accounts say he furnished it with a bed, a desk and a hot plate, hidden in an unused storage room. This allowed him to be on call at all hours without commuting. In an era before mobile phones and constant transport, this kind of proximity was valuable. It also let him keep a closer eye on critical deliveries and solve problems as soon as they arose. The hidden apartment became a minor legend among workers. Some joked that Furman had the shortest commute in Washington. Others saw it as proof of how all-consuming the job had become. It reflected a larger truth of the project. Many on the team treated the schedule as a personal mission, not just an assignment. In wartime, shaving even a few days off completion meant faster coordination of men and material for the front. The clockwise build pattern shaped life on the site. Wedge 1 came first, then Wedge 2, each adding to the loop. As the outer walls rose, crews poured interior rings and corridors. Roads and loading docks took shape alongside walls still open to the weather. This overlapping work demanded precise timing. Materials had to reach the right place without blocking access for other crews. On wet days, trucks bogged down in the soft ground, so temporary plank roads and gravel pads were laid to keep supplies moving. Adding the fifth floor midstream increased these logistics challenges. Scaffolds went higher, lifts carried heavier loads, and formwork had to be adjusted for the new height. Yet the phased approach meant changes could be absorbed without tearing down what was already in place. The symmetrical design also helped, since each wedge was a mirror of the others, reducing the need for custom alterations. By the time the last wedge was finished, parts of the building had been in active use for months. Early occupants had learned to navigate construction hazards, stepping around barricades and ducking under scaffolds. For some, the memory of working in offices with the smell of wet concrete and the sound of jackhammers never faded. For the builders, it was proof that speed and function had taken priority over ceremony. The job had started on a September morning in 1941 with a groundbreaking in front of a modest crowd, and within 18 months the full five-sided structure stood complete, a product of constant motion, tight coordination, and a shared sense that every day counted. The Pentagon reached full completion in February 1943. The final cost was about $83 million, higher than the first estimates, but still within the wartime tolerance for a project of that scale and urgency. By the time the last crews cleared their tools, thousands of clerks, officers, and civilian staff had already been working inside for months. It became the largest office building in the world, with more than 6 million square feet of floor space, and it housed the War Department at a time when the United States was fighting across two oceans. During the rest of the war, the building was the hub of military planning and coordination. Messages from overseas commands flowed in by wire, teletype and courier. Orders for troop movements, supply convoys, and air missions were drafted, approved, and sent out in cycles that ran day and night. The design proved its worth. The rings and spokes allowed officers from different branches to meet quickly, pass decisions along, and return to their desks without losing time. The courtyard, at first an empty open space, became a place for staff to take short breaks in between long stretches at their posts. War maps hung on walls, colored pins marked advances and setbacks, and the noise of typewriters never really stopped. The building's layout, efficient for those who knew it, confused many who didn't. The repetition of corridors and identical wedges gave it a maze-like reputation. First-time visitors often found themselves walking in the wrong ring or circling the wrong courtyard wall. Even people who worked there for years could take a wrong turn if they were distracted. The pattern of corridors meant you could be only a few feet from your goal but separated by several walls and a locked door, forcing a long detour. This reputation became part of its identity, both inside and outside the military. The most famous example of that confusion came decades later, in 1989. Dick Cheney, then the newly appointed Secretary of Defense, set out to visit the Navy Command Center in the Pentagon's basement. Without an escort who knew the exact route, he became lost in the lower levels. Reports said he wandered for some time before finding his way, and the story quickly spread through the press and among staff. The incident became a shorthand for how easy it was to get turned around inside, even for the person in charge of the whole Department of Defense. Over the years, the Pentagon's profile became a symbol in itself. The aerial view of its five-sided shape was instantly recognizable. Photographs and film often used it as a visual shorthand for American military leadership. Its design, once the product of a specific site constraint and a wartime construction race, came to stand for the institution it housed. Like the Capitol or the White House, the building's outline was enough to convey the idea of national power and policy. Its scale and role also made it a workplace unlike any other. It housed tens of thousands of people from different services and civilian offices under one roof. Uniforms from every branch mixed with suits and civilian clothes in the corridors. The building's utility outweighed its architectural ornament, but over time its plain concrete and disciplined lines became part of its character. Veterans of Pentagon service often spoke of walking the rings as part of their daily routine, a habit that tied them to the building's unique logic. During and after the war, the Pentagon's operations touched every theater of combat. The offices inside coordinated supply routes to Europe, managed the logistics of the Pacific Island campaigns, and oversaw the expansion of the armed forces. From its conference rooms came the directives that shaped strategy and sustained the fight. Staff moved in and out as assignments shifted, but the building remained the constant point of contact for the nation's military effort. By the end of World War II, the Pentagon was firmly established as the center of U.S. military administration. It had grown beyond its original purpose as a headquarters for a single department. In the public mind, it was no longer just a building, it was the Pentagon, an idea, a command post and a piece of national identity, all bound in the same five-sided frame. Some buildings that came to define their cities were never meant to be what they became. The Eiffel Tower was built as the entrance arch for the 1889 Paris World's Fair. Many Parisians saw it as an eyesore and wanted it torn down after the fair ended. Its designer Gustave Eiffel defended it as an engineering marvel and a symbol of progress. What kept it standing at first was its value as a radio tower, not its beauty. The public slowly changed its view, and the same spindly iron frame that critics mocked became one of the most recognized structures in the world. The Sydney Opera House tells a similar story in a different setting. The winning design, drawn by Danish architect Jørn Utzon, showed soaring white shells that looked like sails. The plan was unlike anything the judges had seen. When work began in 1959, no one knew exactly how to build it. The shapes required new construction methods and pushed costs far beyond early budgets. Political fights drove Utzon to resign before the building was done. For years the Opera House was seen as a costly mistake. When it finally opened in 1973, the design's originality and its setting on the harbour began to change opinion. Today it is the emblem of Sydney, used as a symbol on everything from tourism ads to postage stamps. The Pentagon's shape and design belong to this group of accidental successes. The original five-sided outline came from the irregular Arlington Farm site. When the building moved to Hell's Bottom, the shape no longer matched the land, but the team kept it. They did so because the plan was ready, worked well for movement inside, and could be built fast. It was not meant to be a landmark. The goal was to get a vast office working during a war, yet the outline became a visual shorthand for the US military, as recognizable from the air as the Eiffel Tower is on the Paris skyline. One lesson from this is the power of momentum. The Pentagon design was drawn in days, approved in weeks, and under construction in months. Once the plan met the basic needs and showed it could be built with the resources on hand, the push to start work outweighed the case for redesign. Each step forward locked in more of the scheme. Stopping to start over would have cost weeks in a year when weeks mattered. The Eiffel Tower survived in part because dismantling it would have been costly, and its new role as a radio mast made tearing it down less appealing. In both cases, the weight of what was already built made reversal unlikely. Necessity also shaped the outcome. For the Pentagon, the need was centralization of the War Department in the shortest time possible. Every design choice was tested against that need. Straight walls beat curves because they saved time in formwork. Repeating wedge layouts saved time in drafting and construction. The rings and spokes let people work without long walks or delays. The Eiffel Tower's shape was dictated by the need to stand taller than any other structure of its time while using the least possible material. The Opera House's sails solved a need for a dramatic, iconic form that would draw attention to the city's cultural center, though solving the structural problems took years. Adaptability is the third lesson. The Pentagon plan was adapted from a site-specific outline to a regular Pentagon without losing its core advantages. The addition of a fifth-floor mid-project shows the flexibility of the design structure. The Eiffel Tower adapted from a fair centerpiece to a communications hub to a tourist attraction. The Opera House adapted from a troubled, unfinished work to a fully functioning performance venue that could host everything from symphonies to light shows on its sails. In each case, the original concept proved open to change without losing its identity. It is worth imagining what might have happened if the Pentagon had been forced into a rectangle or a tower. The movement patterns inside would have changed, and some of the short, direct routes between offices would have been lost. The building might not have gained its iconic profile. Yet in 1941, these points were not part of the decision. The choice to keep the Pentagon shape came from speed and the ability to build with the least disruption, not from any desire to create a symbol. The accidental nature of the success also shows the limits of prediction. Gustave Eiffel defended his tower, but he could not have known it would draw millions of visitors each year for more than a century. Utzon believed in his shells, but he did not live in Australia to see them celebrated. Somervell and Groves wanted a headquarters to work. The fact that its aerial outline would one day appear on television and in news photographs as a stand-in for the entire military was not part of their thinking. In each story, the result met an immediate need first, and only later took on a broader meaning. The Eiffel Tower answered the need to amaze visitors to the fair and prove the skill of French engineering. The Opera House answered the need for a cultural landmark, even at great cost. The Pentagon answered the need for wartime efficiency. None were built with a focus on public affection, yet each found it. The design process of the Pentagon also underlines how much can be done when decisions are concentrated. Somervell gave his team a weekend to produce a plan. He did not ask for a design competition or a long review process. Once the president approved the general approach, construction began while details were still being worked out. Changes like adding the fifth floor were handled on the move. This approach carries risks of mistakes and oversights, but it delivers speed. In wartime, that speed can matter more than polish. The Eiffel Tower was also built in just over 2 years, a remarkable pace for its size. The Opera House, in contrast, took 14 years, slowed by design changes and political disputes, though its final form is now praised. What links these cases is that none of them were perfect in their first form, yet their core ideas were strong enough to endure. The Pentagon's core idea was a low, wide building that kept all the War Department's offices in one place and reduced the time to move between them. The Eiffel Tower's core idea was a light but tall structure that could stand as a feat of engineering. The Opera House's core idea was a group of sculptural forms on a harbour site that would stand out on the world stage. When looking back, it is easy to see the outcome as inevitable. In reality, each was shaped by chance, constraint, and the will to push ahead despite doubts. The Pentagon's 5 sides were an accident of an abandoned site plan. The Eiffel Tower's survival was an accident of new technology needing a tall platform. The Opera House's final form was an accident of structural solutions catching up to a bold sketch. Each case shows that success can grow out of a mix of urgency, adaptation, and persistence more than from a fixed vision at the start. The Pentagon became part of the United States identity almost from the day it opened. Its shape was easy to recognize, even from poor quality aerial photos, and its function was clear. This was where the nation's military leadership worked. As the headquarters for the War Department during World War II, and the Department of Defense afterward, it stood for the scale and reach of American power. For those who worked inside, it was a vast office building with long corridors and routine meetings. For people outside, it was a single image that represented the armed forces as a whole. Over time, that image became part of how the United States presented itself to the world. In newsreels of the 1940s and 1950s, the Pentagon appeared in establishing shots before stories about troop deployments, weapons tests, or strategy meetings. In photographs of military leaders, the building's facade or courtyard often served as a backdrop. The outline from above, 5 equal sides and a central court, began to appear in editorial cartoons, government publications, and recruiting posters. It worked as a visual shorthand. No caption was needed to explain what it was. In the Cold War, the Pentagon's image played a role in propaganda from both sides. American materials used it to project strength, stability, and order. A shot of the building from the air, paired with images of carriers at sea or missile silos, was meant to suggest that all military activity was directed from one central competent source. Soviet propaganda used the same image to portray the United States as militaristic and dominated by its defense establishment. In either case, the 5-sided shape needed no introduction. It had become a symbol in itself, separate from the building's daily work. Film and television reinforced that status. Fictional generals or defense secretaries in movies were shown walking the halls of a set meant to resemble the Pentagon's corridors. Political thrillers used its image in opening credits to signal that the plot would involve military power or high-level secrets. Documentaries often opened with the aerial view before cutting to interviews or archival footage. Even comedies and satires used the building as a prop, counting on the audience to understand its meaning instantly. In domestic politics, the Pentagon's image could be used in speeches and campaign material to signal support for the military. Candidates might be shown visiting the building, shaking hands with uniformed officers, or standing with it in the background. It served as a way to tie a politician's message to national defense without saying much in words. The building's solidity and symmetry conveyed an idea of discipline and permanence. The attacks of September 11, 2001, gave the Pentagon a new layer of symbolic meaning. That morning, one of the hijacked airliners struck the building's west side, killing 125 people inside, along with the passengers and crew of the plane. The strike showed that the headquarters of the world's most powerful military could be hit in its own capital. The images of smoke rising from the damaged wall were broadcast worldwide within minutes. For many Americans, Seeing the Pentagon burning was as shocking as seeing the World Trade Center collapse. It was an attack not only on people and infrastructure, but on the symbol of U.S. defense itself. In the years after 9/11, the Pentagon became a point of focus for security symbolism. The repaired section, rebuilt in less than a year, was presented as proof of resilience and speed in the face of attack. Ceremonies on anniversaries of the attack took place at the site, with the building as both backdrop and participant in the ritual. Its continued operation, even on the day of the strike, became part of the story told by military leaders. The headquarters never closed, the work went on, and the institution held firm. This security symbolism extended into media and politics. Images of the intact building after the repairs were used to support messages about preparedness and strength. In films and television, the Pentagon was shown not only as a place of planning, but also as a fortress-like structure, guarded and resilient. In political speeches, references to the Pentagon often carried both its literal meaning as a location and its symbolic meaning as the embodiment of national defense capability. The post-9/11 security posture also altered the public's relationship with the building. Before the attacks, guided tours and some public access were possible. Afterward, the visible perimeter defenses grew. Fences, barriers and controlled entry points reinforced the idea of the building as a protected command center. Photographs from outside often showed these defenses, which in turn became part of its public image. For supporters, this reinforced the notion of vigilance. For critics, it symbolized the growing separation between military leadership and the public. In popular culture, the Pentagon's post-9/11 image often carried a dual meaning. It could stand for the nation's ability to recover and defend itself. It could also be used in stories that questioned the role of the military in policy decisions. In both cases, the five-sided outline remained the same, instantly readable, carrying decades of association with war, defense and national purpose. The building's use in media, propaganda, and politics shows how architecture can take on meaning far beyond its practical role. The Pentagon was built to solve a problem of space and efficiency in wartime Washington. Its distinctive shape came from a site plan that no longer applied, yet over time, it became a symbol with layers that shifted as events changed: wartime coordination, Cold War power, political allegiance, vulnerability in the face of attack, and resilience afterward. Its image could be framed to inspire pride, fear, or resolve, depending on who used it and why. The simple geometry that once saved construction time became a sign recognized across the world, carrying the weight of the institution it represents. The Pentagon has never been static. Since it opened in 1943, the building has been under almost constant maintenance, and in recent decades it has gone through large-scale renovations. The work has aimed to keep the building useful for a modern defense department, while preserving the structure that has become part of national heritage. The challenge is that the Pentagon is both a historic landmark and one of the busiest office buildings in the world. It must operate every day while parts of it are under repair or upgrade. By the 1990s, much of the building's infrastructure dated back to its original construction. Electrical systems, plumbing, heating, and cooling all needed replacement or major repair. Communication cables installed for teletypes and early telephones had to be replaced with fiber optics and secure digital networks. Office layouts built for typewriters and filing cabinets had to be adapted for computers, classified data systems, and secure video links. The Pentagon renovation program, often called PenRen, began in the mid-1990s to address these needs. The project was phased so that entire wedges could be emptied, stripped to the concrete, and rebuilt while the rest of the building stayed in use. The work went beyond replacing worn-out systems. Modern building codes required fire suppression, improved exits, and stronger structural elements. Security concerns meant adding blast-resistant windows, reinforced walls, and controlled access points. These changes had to be blended into the original structure without altering its appearance from the outside. In practice, that meant using modern materials and methods in ways that kept the same profile, proportions, and finishes. For example, new windows were designed to look like the originals, but built with laminated glass and heavy frames to resist damage. Balancing heritage and upgrades required detailed planning. The Pentagon's status as a historic property meant that changes had to be reviewed for their impact on its character. Preservation specialists worked alongside engineers to find solutions. Original terrazzo floors were repaired or replicated. Corridor dimensions and ring layouts stayed the same, even when interior walls were rebuilt. Light fixtures were upgraded for efficiency and brightness, but the style was matched to the 1940s originals. The goal was to keep the building recognizable to someone who had worked there in the past, even as its systems were completely modernized. Some changes were driven by events. After the 9/11 attack damaged the building's west side, the repairs included new structural reinforcements and fireproofing that became models for the rest of the renovation program. The rebuilt section, known as the Phoenix Project, was completed in less than a year and demonstrated how the entire building could be brought up to modern standards while remaining in full operation. Features like wider stairwells, improved sprinkler systems, and compartmentalized utility runs became standard in later phases. Keeping the building functional while modernizing it required unusual working conditions. Construction crews worked in secure areas, often at night, to avoid disrupting sensitive operations. Demolition and heavy work had to be planned around the schedules of offices that could not shut down. Materials were brought in through service corridors to avoid public entrances. In some phases, temporary bridges and passageways were built so staff could move between rings without passing through active construction zones. Despite changing defense needs, the Pentagon has remained relevant as a headquarters. The original design, with its rings and spokes, still supports fast movement between offices and departments. Technology has reduced the need for some in-person contact, but classified work often requires secure spaces where people can meet face-to-face. The building's size and layout allow entire commands to operate in one place, with support services nearby. Modern conference rooms, command centers, and secure communication hubs have been built into the structure without altering the flow of its corridors. The building's ability to adapt has been tested by shifts in military organization. During the Cold War, the Pentagon focused on conventional forces and nuclear strategy. In the post-Cold War era, it adapted to handle counter-terrorism, cyber defense, and new forms of conflict. Renovated spaces have been configured for joint operations, bringing together personnel from different branches and agencies in ways the original layout did not anticipate. The open courtyard, once just a space for fresh air and walking between wings, now hosts events and gatherings that support a broader community inside the building. Preservation also serves a symbolic role. The Pentagon is not just a workplace, it is a national icon. Its appearance must remain familiar to the public, even as its interior changes. This means that the building cannot be replaced by a new headquarters elsewhere without losing part of its identity. Renovation allows it to continue to serve both functions as a living working command center and as a piece of history tied to the nation's military story. The balance between old and new is visible in small details. In some corridors, the original 1940s wood trim has been refinished rather than replaced. Original doors have been rebuilt with modern security hardware hidden inside. Historic display cases still line certain halls, showing artifacts from the building's past, while just a few steps away are secure rooms filled with the latest defense technology. The mix of errors is not accidental. It reflects the decision to keep the building's character even as it serves a very different set of needs than it did in 1943. Modernization has also meant improving the building's efficiency and sustainability. New mechanical systems use less energy and provide better climate control. Lighting upgrades reduce power use while improving visibility. Plumbing replacements save water. These changes have been integrated without altering the building's historic profile, proving that preservation and sustainability can work together. The Pentagon today is both familiar and different from its wartime self. The rings, spokes, and central courtyard remain. The exterior still shows the same five-sided symmetry that was set in the first week of design. Inside, however, almost every system has been replaced or rebuilt. It functions as a 21st century command center inside a mid-20th century shell. The success of this balance comes from the same qualities that shaped its original construction: the ability to adapt, to work within constraints, and to keep moving forward even while the building is in use.